Okay, so today's class is important. I mean, this is the crux of Java, we can say, or any object-oriented programming. See, these OOPS concepts. So understanding them is very important from interview point of view because there are two types of interview questions that typically we will see in Java. One are the questions related to programming that we discussed earlier during discussion of fundamental concepts, for loop, conditionals, arrays. So there are some programming problems given from there. So that is one aspect which is typically asked to junior level members who are entering the software industry. So OOPS concepts are something that are kind of more advanced level. These are asked from people who typically say we have designed softwares, because object-oriented programming is about the software architecture. How do we look at a problem statement? How do we solve it in an object-oriented way? How do we come up with classes? What are the relationship between classes? How do we add functions? How do we enforce code reuse? So these concepts are geared towards that. So let's begin with our today's discussion. So yesterday we talked about there are four OOPS concepts. I'm beginning with a summary. First is abstraction, then inheritance, then there is encapsulation, and the last one is polymorphism. So these four OOPS concepts are there. And what we will do is we will be covering these concepts with a live example. So we will be building something concrete, and we will see how these each one of these concepts play a role in building a software. And each of these concepts have certain sub topics under them. So if we talk about abstraction under Java, then there are four concepts that are typically that fall under abstraction. So one is interface, then abstract functions, then abstract class, then there is an implements keyword. Then there is inheritance. In Java, there are keywords like extends and super keyword. These fall under the category of inheritance. Encapsulation has the concept of package and access modifiers. And polymorphism has two concepts, operator overloading and overriding. And all of them we will understand, and then again we will come back to the same slide, and then we will see we'll do a checklist kind of review of all these topics that are listed here, just to see do we understand each and every concept that is listed here in detail or not. So if these are the concepts that are mastered, then we can say to anyone like we understand what Java is, and we can kind of delve into the details of making softwares in object oriented way. So before even we begin, Sarita, you have any question?
No.
Okay. Yeah, so before even we begin with the software development history, let's talk about constructing a building. So let's imagine we are a builder who constructs the buildings, houses, flats for people, and this is what we have to kind of make. So let's say as a builder, what we have is we have the land with us. It's a raw land on which we want to make this building. Now, this is some dream that we say, okay, this is something is the end product that we want to build. We will have a discussion on this. How do we start constructing a building? What are the steps involved? And then we will apply the same knowledge in parallel to see how software is constructed, because constructing a building and constructing a software, they have a lot of similarities with each other. So let me put that as a question. So Sarita, let's say we have got a piece of land and we have full rights on that, and we have to start constructing that building. Let's assume raw material is also there with us. Workers are also there with us, because when we build software, we say raw material for us is a laptop and then the programming knowledge. Workers are the peer programmers that we have in our team. So that also you can assume we have. Land also we have. Having all that with us, the full workforce is there with us. What is our starting point for this constructing this building? So where does a builder start? Yeah.
Foundation.
Okay, so foundation we form. So absolutely we will begin with the foundation. We'll dig into the ground. So that digging is something that workers will do. But before even we dig, we should know how much area we want to build into, right? How many
Yeah.
floors we want to build, then each floor, what will it look like, because foundation is essentially the walls in the building or the pillars of the building on which the building rests. Even the rooms in the building or balcony in the building will rest upon. So we should know where to put the pillars and all, right?
Yeah.
So in order to know where the pillars should be, who will we consult? Who will tell us these are the places where you should put the pillars?
Yeah. Maybe architecture.
Absolutely. So we will go to an architect and we will say this is the piece of land we have. On each floor we want to have 4 flats. We want this much common area, this much area into the flat. Can you build a nice architecture so that we can utilize our space properly and we have maximum space given to the flat owners? That is where we reach to an architect, right?
Yeah.
Now, what does an architect do? An architect starts by drawing a raw map, or we can call it a floor plan. That is what an architect does, right? He will be very specific with the measurements and he will create something like this. Agree?
Yeah.
Yeah. So this is the build starting point, and right side we see the ending point. Before even going to the starting point, to architect we will tell our requirements. So requirements are already given to us, and based on that we reach out to architect and say, just give me the best utilization of space. So what architect does is he puts something on paper and sends it to us. Now this plan that we are looking at on paper, this is not the real flat that we can live in, right? This is just conversion of our requirements to some standard, correct?
Yeah.
Yeah. So from this starting point going to the end, it takes one middle level, that is building will be constructed step by following the plan that we specify over here. So sometimes some builders, what they do, they start constructing the building, they put the uh, foundations, and in parallel they create a model flat, which is just a flat with some cardboards as well as some temporary walls they construct, so that the customers who are ready to buy their flats, they can come, they can have a feeling of how the flat is going to look like. This is little more advanced version of the map that architect has drawn. So this we can say is kind of a model flat that we can walk around and see. There will be switchboards, there will be some temporary stuff kept inside, but still we can say the middle level is also not ready to occupy. But it gives more nice look and feel of how the flat is going to look. So these are the phases through which we go when we construct a building. Now let's look at these phases from object-oriented point of view. So if object-oriented point of view, if we talk about the first layer, the first map that is there on the paper, it is called abstraction. Now what abstraction means is, abstraction is kind of a suggestion or a standard that is laid out. So abstract plan that we have, the term abstraction means we are looking at only the necessary and relevant details of a system. For an example, if I say we are going to buy a mobile phone, or if I say I'm going to buy a car, then automatically in our mind comes, if you are going to buy a car, it will have 4 wheels, it will have a steering, it will have a brake. Inside the car, we will have an AC. So there are some standards that are already fed into our mind. If I say we have to construct a car, then also these standards remain in our mind. We have some level of understanding that car requires these things, and we can lay out those requirements and we can kind of make a model of the car by putting those requirements. But that model is not the real software. So that is where abstraction fits in. If we have to summarize the term abstraction, we will say laying out just necessary details of what a thing is rather than worrying about how the thing will be built. So the person who makes this map, he doesn't worry about how the builder is going to build this building, how he will get the labors, how he will get the cement, what material he will use. But the goal of this person is to just give a fair idea of what it is going to look like. So we can say, if we have to write in one line what abstraction is, and in a layman's term, if we have to understand, abstraction is focusing on what rather than how. That is abstraction. If we are focusing on what part, not the how part. And in technical language, if we have to say, this is looking at necessary details of software without worrying about implementation. Now this is the layer of abstraction. Well, so after abstraction, we move on to the next layer, which is the middle layer. Then we apply inheritance and polymorphism, and we construct some model house, or we start building. You can also say this is a model house, or this also represents the unfinished building where the work is still going on. So what builder does during that time, he applies the ideas of the buildings he has constructed already. So he uses some of his experience where he built another building, and he will say, okay, in that building, this is how we constructed. Initially, we put few labors because we were doing just the foundation. Then we needed double the labors when we were doing the wall, kind of we were erecting the walls. Then when we have to plaster the walls, we will need more people. So that's kind of experience applies, and he start inheriting from his previous experience. So inheritance is kind of reusing. The goal of inheritance is reusing the existing functionality. So if you have something already existing, or if you have built something in past, how can we reuse that so that we can build the software quickly and we have to put less effort in building that. So inheritance, we will see with an example going forward, that inheritance is all about reusing the functionality rather than duplicating it. So that is how we should write it. So it means if we have written some piece of code already into our software, and if same functionality is required somewhere else, then what we can do is we can reuse. Then there is polymorphism. Polymorphism, we will say it's like little twisted concept, and this is the interviewer's favorite concept for interviews. So polymorphism we will come to in next week's class. Polymorphism. So that we will cover theoretically in next week class. We may use some parts of polymorphism today. So polymorphism I'm leaving intentionally as of now. So let's say builder applies his previous experience, inheritance, and then he applies polymorphism. Then what he does is, after the building is erected, it will not look as furnished, as finished as the end product looks like, because in walls somewhere he would have put some pipes, he would have done some electric work. So walls will look like they will be opened and we can see the pipes in the walls. So there are certain details that we can still see in the flat. We can see the sewerage pipe, we can see the electrical pipes. Then what builder does, he goes and he closes those things so that they are hidden from us. We should not be seeing those unnecessary details. They are hidden from us so that they can give the nice finishing. So when they hide the unnecessary details, that is called encapsulation. So encapsulation is hiding unnecessary details that initially were accidentally exposed to us. Polymorphism also, rather than going into details of that, if I have to write here, then I'll write in this way. When we are reusing the functionality, existing functionality, sometimes we cannot use our experience as it is. We cannot use the functionality as it is. We have to customize it. Let's take an example. If in cooking at home we have experience to make food for 3 people at home, and then suddenly one day we have to cook food for 10 people, then our same principles of 3 people will not apply, but some tweaking will be required. That means for 3 people, if we use some amount of rice, if we use some amount of dough to make chapatis or bread, then we have to multiply it accordingly based on the number of people. We have to take another factor in, that in the new set of people, how many are kids, how many are ladies, because each those category, they will have different eating amounts that they consume. So we can say polymorphism is all about using experience with customizations. We tweak something and then we use it. That is where the polymorphism will come in. So this is like a building way or construction way of understanding or looking at these 4 concepts. Now we will see how each one of them applies to the software building. So last one that I showed here was encapsulation. Okay, yeah, so this is encapsulation is here. Well, so let's proceed further from here, and we will see the same concepts we will apply in building this fruit bazaar is a small UI application where what we are doing is this represents a small shopping cart. And in this in this shopping application, we are just selling three things. We are selling a pineapple, we are selling apple, and we are selling pomegranate. So we'll say this application should have an option to sell three items, as well as the software should be designed in such a way that in future if we want to add three more items or 10 more items into this, it should be scalable and extensible to add support for more items. Then the functionality that we have is, if we do plus here, if we click this plus button, that means we are buying this product. So if we are buying this product, here initially items will be 0 and total amount will be 0. That's the total of our shopping cart. So this red area represents our shopping cart. This complete application represents an e-commerce mini version of an e-commerce application. And we will see how we apply the concepts of object-oriented programming here. Now, before we move forward, it is necessary that these concepts are there in our mind in some way so that they are easy to understand. So let's do a quick recap of what we talked about. So Sarita, whatever you have understood till now, let's do a quick summary of that so that these things are settled in our mind and we can proceed further. So what do you understand by abstraction?
Abstraction is very in these all the concepts. Abstraction is the very important concept because we have to use all the necessary and relevant whatever
is necessary for building something. So that should be clear to us, right?
Yeah.
Okay, so it's ideally we can say it's conversion of requirement into some formal way, technical way, so that is more domain specific. In constructing of building, the map is more specific. In construction of software, we will see. So focusing only on the what part without worrying about the how part.
Yeah.
So if somebody comes today and asks Sarita, how do we, if we want to make a new phone, let's say we want to launch a phone building company, then abstraction is the easiest concept. Giving someone advice is the easiest thing, right? What we will say is you need to go to a plastic making company so that you can buy plastic for foam. Then you have to go to a screen making company so that you can buy screens from them. Then you have to go to a processor making company, you get processor from there. Ultimately, all you have to do is you have to assemble them together. You have to give it your own branding and you have to sell it, right?
Yeah.
So this discussion that we had, it was just an abstract discussion because we are talking about what has to be done without worrying about how exactly it will be done, because how is the more detailed thing. Yeah. Okay, great. So that winds up our abstraction. Next concept was?
Inheritance and
polymorphism. Yeah. So what is inheritance?
Inheritance means using the existing functionality.
Right. So basically using the existing experience or existing functionality, reusing something without duplicating it.
Yeah, reusing.
Reuse, absolutely. Next is polymorphism. What did we talk about polymorphism? Just a non-technical introduction of that.
Yeah, is customizing, right. Using experience with customizing.
Absolutely. So using old experience with some customizations applied to that. That is polymorphism. And the last one was?
Encapsulation.
Encapsulation. What was that?
It was hiding unnecessary details.
Yeah. So whichever does not make sense to show to the user, we should be hiding that for finishing reasons, right?
Yeah.
Awesome. So this understanding that you have, this will help you understand all these concepts with ease, and we will see by the end of today's class, we will see an application up and running. And we may not go into the details of polymorphism today because otherwise it may become too heavy, but we will be using the polymorphism without going into the details of that. Okay. So now if we have to build this application, First thing that we have to think about is what are the parts of this application and what should this application give. So let's say here there is a site with which as a user we are interacting. So this what we are seeing is kind of an e-commerce application. So in Java what we do, the concept of abstraction is we start with an interface. So interface is the concept that we are going to talk about now. Now what is an interface is, it is a kind of abstract view of a class. Class was a detailed view. In class we have certain members. From yesterday's class, Sarita, what all goes in a class? If you are defining a class, what type of members can a class contain?
Data
It will have
members,
data members and
functions or methods.
functions. Absolutely. Now function is something that we define like return type. So first we say return
Or
type, then name of the function, round brackets, then the body of the function. These four parts are essential. Now when we said interfaces are abstract view of a class, then the data members of functions will not be there in the interface. By the way, interface and class are exactly the same with minor differences in them, that interface can have members like class has, but interface cannot have data members. So it's a simplified version of a class. No data members allowed. Instance variables will not be there. Only functions will be there. That means function members will be there. That too without having a body part. So this function has a body, which is the implementation of the function. So it will have the functions without body. That's what an interface will be. Clear?
Yeah.
Okay, so now let's say this thing that we are seeing, we have to represent, and in this application, there is a shopping cart at the bottom that we are seeing. And then there are some interaction points that we are adding an item, or this minus is disabled. That is like if we want to deselect some item, we don't want to buy that item going forward, or we want to remove it. So let's first start with our concept of abstraction. So let me create a class 7 project. Okay, so we select Java, we select Java application, we go next, and here we say this is our class 7. Next, finish. So we have created a project. At a high level, if we say there will be a main form, or we can say main window will be there with which user will be playing. So there has to be a class representing the main form. Then there will be a class. Okay, so since we are starting with abstraction, let's start with main form not as a class, because we want to start with abstraction, and we talked about abstraction is what rather than how. So we say we will have an application. So here I go, rather than adding a Java class this time, what I'm going to do is I'll add a Java interface. We go to Java interface and we call it, this is our shopping cart. So I simply define an interface. Here also if you see, it calls it class name rather than interface name. So you can say that's kind of a bug in NetBeans. They have not called it interface. But internally we can also say like they treat class and the interfaces as same, with just subtle differences between them. So we defined an interface named shopping cart, and you see the only thing that changed in defining an interface with respect to class is here the syntax is public interface shopping cart. Earlier we have used public class shopping cart. So since this is an interface, in this interface we are just going to write the function signature. So what kind of interactions will we have with a shopping cart? So what do we do with a shopping cart? That is all we have to convert here to create our interface, to create the raw map of our software. Yes, Sarita. So what are our interaction points with the shopping cart?
Yeah. We buy.
Correct. So we buy an item. We don't buy a shopping cart, right? So when
Yeah.
there is an item, that item is added to a shopping cart. Is that correct?
Yeah.
So shopping cart should give us some function where we say add product item. This is our function, and I said the functions will not have body in this case, so we put a semicolon here. Now when we are adding some product in shopping cart, it's like putting something in our bag. So what should be the return type of this function? When we are adding some item, yes, Arita. So what return type should I write? When we are in doubt, we will always start with void return type. Okay.
All right.
Later on, we will see if something has to be returned. So if we are in doubt, let's go ahead straight with void. So let's say shopping cart gives us a function add product item. Now which item we are adding to the shopping cart, we should be telling, right?
Yeah.
Because from a e-commerce site, we may buy shoes, we may buy toys, we may buy something else. But in our case, we are doing a mini version of shopping cart. So ideally, we will be telling either add pineapple or apple or pomegranate. So what we will do is add product item will take some input parameter, which will be a product item, right?
Yeah.
And this product item also we don't have defined right now in our project. So we define a new type product item, even that is abstract in our mind. Right now we have not thought about details of that. So what we will do, I'm copying this product item because otherwise compiler will say I don't know what product item is. Let's go here and add a new interface because here we are talking in abstract terms. So we will add another interface, and this interface will be product item interface. So now this makes sense. We have a shopping cart, and in shopping cart we can add item, and product item is the type that we will be adding. What other functions a shopping cart will have? If we can add item to shopping cart, what else can we do?
We can delete item.
Absolutely,
To
we can
remove
we can remove the item or delete the item. So let's add
Yeah.
another function, and here you see the difference between class and this is we are just writing the function signature, which is the return type, function name, and input parameters, and then we put a semicolon. We don't put the curly brackets. So second function you are saying is we need a remove item, remove product item. Let's be specific. So we are removing a product item. Now what input parameter will this function take?
It will take product item.
Yeah. So which item we want to remove? If we have added 10 items, we have to specifically tell this is the item we want to remove. So we say product item P. This item should be removed. What will be the return type of this?
Void, yeah.
Yeah. So let's go with void. That shopping cart provides us two functions. We can add an item, we can remove an item. So now let's assume in our software application, this UI that we see here, this UI is going to use the shopping cart from the backend. So this UI is consumer of shopping cart. So when user clicks the plus button, this UI is going to say to shopping cart, you add pineapple item to yourself. Then when user clicks the minus button, this UI is going to call shopping cart and say remove item from yourself. So these are plus and minus, these are two interaction points of this class which shows the end result to the user with the shopping cart. So we have two classes, one will be the GUI and second will be the shopping cart in the backend. This makes sense till now?
Yeah.
Okay. Now at the bottom if we see, here we are showing the count of items, how many items are there, right?
Yeah.
So who will know the count of items? It will be UI will know or shopping cart will know?
Shopping cart.
Shopping cart will know, right? So UI needs more functionality from shopping cart. So we are saying shopping cart is a guy to whom UI will reach out for every single detail that it wants to show to the user or every single interaction point that user wants to have. So we want to add a function here in shopping cart that is telling to the UI how many items it has. So we have to add one more functions because here we cannot add data members. We just have to add function. So what function do we add so that shopping cart tells us how many items it has? Yes, Sarita.
Wish list, yeah.
No, this is a shopping cart, right? So we have added certain items from our side. So how many items are currently there in the shopping cart? Like on UI, it is showing right now there is item one. If I do one more plus, then this should be updated automatically. This should be two items, and the price will become 25 plus 45. It will become 70. With every plus and minus, this count should update. How it will be updating here is whenever we do a plus, click here, it will go and call the function of shopping cart. It will say add product item. Implementation will have the logic of adding the item to cart. Then UI will also go and check with the shopping cart. Hey shopping cart, can you tell me what is the count now? Now shopping cart will say I have two items, and UI will update it to 2. Then it will go back to shopping cart again and say, hey, can you also tell me the total of the items so that I can display here, right?
Yeah.
So we need two more functions in shopping cart. One function that should tell us how many items are there in the shopping cart. Second function to tell us what is the total price of items that we have added till now. So what I'm asking you is to write two more functions here. One function that tells us outside how many items are there in the shopping cart. So what should be the function name for that?
Yeah, total items.
Total items. So we say total items count. Just be a little more elaborate. Now, does it need any input parameter?
Yeah.
What will be that input parameter to total items?
Yeah, again, product item.
Why? If we are asking how many total items you already have,
not product item. I think it's some integer.
no, that is something it will return,
Yeah.
right? So if I say, as an example, if I want to check SMS in my mobile phone, I don't need to give it any input. I can just, or if I have to check the time on mobile phone, that's more suitable example, simply pick the phone and see on its screen, right? We are not giving it a number like we would have given in calling. If we have to call a number from mobile, we have to give an input, which is mobile number. But if we are just looking at certain thing, if we are getting the value back, we don't give any input parameter. This is making sense?
Okay. Yeah.
Okay. And more specifically, we should write these functions as getters and setter. That will appear more appropriate. Ideally, total item count is also a valid name. But if we say get items count, this goes more with the Java syntax. Right?
Yeah.
Now, what will be the return type of this function? What will this function return back to us?
It will be void.
Read the function name. The caller wants shopping cart to tell how many items it has. How will it tell back? That is where the return value comes into picture. What will this function return? It will say 5, 10, 20, something like that, right?
Yeah, integers.
It will be int. So this is what this function will be. Or take a generic example. If we go to some shop, if we are buying something, so let's say we go to a shop to buy, let's say cheese. So we go to shopkeeper. If we are buying a cheese, it's our interaction with the shopkeeper. So we say get cheese, and let's say cheese comes in pack. So we say get cheese pack. Input that we give is we give some amount, and the output that we get back is cheese. So this is how we reach out to a function signature. What we are giving is input. What we are getting back is output. So in order to get cheese, we have to pay the amount, we get the cheese back. So this is the function signature we reached out here. Now in shopping cart, we are simply saying, tell me the total items we have. It's like going to a shop and we are asking how many products you have in your shop. We are just asking a blank question without giving him any input. We are not paying him money. We are not giving him something tangible. We are simply asking a question. So this question, getter functions are typically asking the questions to a class. So this is making sense now, Sarita?
Yeah.
Okay, great. So one more function we want to add here is that will tell us the total amount of items that have been added in the shopping cart. So let's do that as an exercise again. what will be the function name so that it tells what is the total price, because UI would want to show that here. Like here it is showing rupees 25. So this 25 is something that shopping cart has to tell. So function name will be
get total amount.
awesome. Yeah, get total amount is fine. Or what you were saying? So
Yeah, and the return type will be integers.
Return type will be integer. If we are saying there will be no decimal values, none of the product item has a decimal price. If we say product items can have price like $23.30, then it would have become double or float, right?
Yeah.
So right now we are worrying only about the integral price, let's say. So will this function take any input parameter?
No.
It will not take, because we are again simply asking a question to shopping cart. Awesome. So we are done with an interface. 4 interaction points, and now if you look at this GUI, there are 4 interaction points of us. We can do plus and minus, that is where we worry about, and based on this plus and minus, these two things will change here, this number and this number. Right, 2 points with which we interact and 2 places where we look for the output. So these are our input functions, these are output functions, and that is the functionality of shopping cart that we have been able to abstract in terms of Java. Clear?
Yeah.
Okay, so now one thing to notice here is these are the functions without body, and whenever we have a function without their body, these functions are called abstract functions because they do not have their implementation with them. So these are abstract functions. So interfaces can have only abstract functions. If I try to put a body for any function here, we'll get a compiler error, because you see here it says interface abstract methods cannot have a body. That's the rule of Java. So we remove it and we put a semicolon here. Now Java has a keyword called abstract, because whenever a function is abstract, we can put a keyword in front. We can say this is an abstract function. For all the functions we can put the abstract keyword, but since an interface can never have a function body, what Java people said, let's make this keyword optional. Even if you don't put abstract here, by default we will consider all the functions that you declare inside an interface. By default they are abstract function. So writing abstract or not writing abstract, they still have the same meaning, that this function is also abstract, this is also abstract. So kind of we are relieved from writing abstract keyword here. Another thing is all the functions in an interface are by default public. Now public is also assumed internally. Whether we write it or not, all the functions that we are defining, they are by default public and abstract. So this is another learning point that with which we can say we have covered our interfaces in detail. That's all about interfaces. So if we have to summarize the discussion of interface, we can say, what is an interface, Sarita?
It's an abstract function without body.
So it contains only function members,
Yeah.
functions without body. So it can contain only abstract functions, right?
Yeah.
This is the first takeaway from interfaces. Second is, by default, all functions declared in interface are public abstract. Whether we write public and abstract or not, they are implicitly public and abstract. So we have a choice of writing public and abstract, or even if we leave that, if I leave only public, still this line means this is public and abstract both. Because if we are not writing anything, compiler adds them automatically for us. Okay, so clear about the interface concept?
Yeah.
Okay. So let's take a look at the second interface. Second interface that we declared was a product item. Now typically a product item, what kind of functions will a product item give? So if a pineapple is a product item, apple is a product item, pomegranate is a product item, what are the commonalities between them? Each product item is having an image here, right?
Yeah.
So we can say every product item will have a function to which we will say get image. Since this is a getter function, no input will be given to it, and what it will return us back is an icon. So icon is a Java class, so we can directly reuse it rather than defining another abstract entity. So every product item must have an image because that's how our e-commerce site is being built. Then every product item should have a name, like it's the pineapple, this is apple, this is pomegranate. So we are making some rules for that. So it will have a get name, which will be the name of the item. Return type will be string because name is typically a string. Then it will have the price of item. So we can say get price, or we can say it's get unit price, so that for one item we know what is the price. What will be the return type of this?
Integers.
Integer, because we are talking about the non-decimal prices. So
Yeah.
well, so abstract details we have laid out. We are saying in our software we are going to have one entity called product item, another entity called shopping cart. Now the third thing that we are going to have is a graphical interface, this form, so that we can show something to the user. So for that, what we will do, we will add a class now and we will start implementing the code. So JFrame form we add and we say this is mini bazaar, and we enter, and we can see we have got a nice UI created by default by NetBeans for us. Now we know to create this UI, what it takes is simply drag and drop of certain items. So to show an image, what is the control that we took yesterday for showing card image? Remember yesterday we did the card application.
Yeah.
So what did we drag on which we were able to show the images? So we dragged some controls from here. Buttons, toggle buttons, label. Remember?
Yeah.
Label?
Labels. Yeah.
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 So labels provide us flexibility. They provide us a function called set icon, using which we can set any image here if we have the image path. So same thing, knowledge that we discussed yesterday, we are going to use it today. Then on top, this plus and minus, what are these?
Those are buttons.
Those are buttons. So we go here, there is a button here. Let's drag a button and leave it here. For the first item, now we can edit the text and we can put a plus symbol here. This will be adding of this item. We can drag another button. This will be minus symbol, adding of another item. Then same way we will drag and drop other buttons, because if we are adding 3 items for now, we'll have 3 pairs of plus and minus buttons. So we do edit text and we do minus. Then again we drag a button here, again a button here. Every time we are right clicking, we are doing plus for one and we are doing minus for another one. So this is 3 pair of buttons we have in order to make this UI. Then one label we have for the first item. Let's drag a second label for second item. So we drag a label, let's make it bigger. Now what happens is, these labels and the frame, they have the similar background, so that's why it is becoming hard for us to spot the kind of difference between labels are there or not. So whenever we want to select a label, we can always go to this navigator. It is showing what controls we have added. So this makes it easy, because right now at least we have the text. If we go and remove the text, then it becomes hard to spot where is the label that we added. And like yesterday we removed the text, today also we are removing the text. Otherwise the text will appear with the image and that will look little ugly. So let's make this label little bigger and we drag a third label to show the third image, that is here. And let's drag and drop and make it a little bigger. Right click, edit text and remove. So we have got 3 labels to show 3 images. So okay, this row is also nailed. Now let's take 3 labels to show the item name. So this will be the name of the item, this will be name of the second item, and this will be name of the third item. After we have got the names, we have to show the price. So let's drag 3 more labels. This label will show the price of first item. This label will show the price of second item. This will show the price of third item. Now after this, what we have to show is we have to show the total number of items and the total price. For that, again, we can drag two labels, one label to show total items, another label to show total price. And we are done with dragging and dropping of our controls. So for now, let's do one thing. Let's get the images for these items so that we can show these items on our desktop. So E being 0, so it should be there in one of the previous batches, shopping cart, fruit images. So I have this folder where I have these three images. Now if you want to make it for any other product item, you can put image of shoes, then milk, then headphones. Like ideally, if we want to make shopping cart for other items, we just need to change the images. So let's copy this folder. Now this folder should be copied to the project folder. So I can go to class 7, go to properties, and here on top we get the folder path where our project is stored. We go to the project folder, and that is where we will copy the images. So I'm copying fruit images and I'm pasting it here. So that way our application will be able to use the images. Now if ideally we don't go object oriented route, then it's very easy for us to set these images. We can go to code, we can use the function in a class. JLabel gives us a function set icon which takes an image icon, and with that we are done setting the images. So that we can do. But if we are building things object oriented wise, then ideally we should be relying on a class which is giving us this image. So what we will do, we will do it object oriented way so that our system is extensible to use any kind of product. So our UI will rely on this product item interface to get the image, to get the name, and to get the unit price. And output of these three functions will be used at our UI. So we'll see that in a short while from now. Okay, so layout wise we are ready. Another thing which is little beautification, we can see these prices that we are showing, they are shown in blue color. So if we want to change our labels, so I can select these labels one by one. I'm holding the control key and I'm clicking on these labels, and on the left side we can see label 7, label 8, label 9 are selected because they are gray in color. After selecting them, we can right click, we can go to properties, and in properties we have a hell lot of properties to change the settings. So we don't need to understand each and every property because it will be overwhelming if we start learning what each and every property is. Need by need we will see what all is good for us to learn. Now the thing that we want to do is we want to change the color and we want to change the size of the font. So for that, let's try to search if there is any font property. We can see there is a font property here. There is a 3 dots on the right side of every button, so we click that and we can see font is typically comprised of 3 things: the font family, font style, and font size. So let's make the style bold. Let's increase the size from 13 to, let's say, 18, and we say OK, and we will see all these labels have become bold. Now second thing that we want to achieve is we want to make the color of label as blue. Now let's search for some other property, and we can see there is a foreground property, foreground and background. Background means what is the background of this label, and foreground is what is the foreground color for the text. So we go to this, we click this button, a small button on the right side, and it allows us to change the color. So let's pick some bluish color and we say OK, and we can notice all these 3 labels have become blue for us. Same way, if we want to make the bottom 2 labels as red, we can select first, then we can hold the control key, we can select second, right click, properties, change the color to red or any other color that you may like, then go to font and increase the font size to, let's say, 24, and let's make this as well bold, and we say close, and we can see these 2 labels are also changed in color. Now if I go and right click and if we run this, we will see when this application runs, it has all the dummy details because right now we have not filled the item name, we have not filled the item's price, we have not filled anything in these details, in shopping cart details. So that's why it looks like this. So Sarita, so far so good?
Yeah.
Awesome. So if you have any doubts anywhere, just stop me and you can ask, because we'll be covering a lot of concepts by building this application today. Now here we have to show items and their count. So what we can do is this text label, let's do right click, edit text, and we say items, and in the round bracket right now we put 0 because that is what we want to show initially. And we can also put a colon here, right click, edit text, 0 and a colon. That is the text we are showing in the first label. Second label, we right click, edit text, and we say rupees 0. Or if you want to show it as dollars, you can put a dollar symbol and we can say dollars 0. That is what the total price right now is for us. So now if we run it, run file, we can notice that this is the total value of shopping of items that we have shopped for now. If you want to increase the frame size, font size, we can just drag and drop this frame a little bigger. So now whatever we have done till now, it's all abstract because we did not go into the details of implementation of each of these things, but we have done something at abstract level. Now we should start delving into the details of how we build our software to second level, because we started with this abstraction, that is what we have laid out in the form of interfaces. Now we have to proceed towards the end product, which is this. So we have to somewhere use the concept of inheritance and polymorphism. So before we use inheritance and polymorphism, the main thing we should understand is we should try converting our abstract things into actionable things. An actionable thing is always a class. So the interface that we had laid out, this was just specifying the requirement in Java terminology. So if we are implementing this, if we are writing a class which will implement this interface, that class we really need so that our mini bazaar can use the class. So now we are going into the details of inheritance, that we should have some product items which are having the functions like product item is telling. So Apple item should have its own image, it should have its own name, its own get unit price. So we need a class like that. So what I'm doing is now we are entering into the implementation details. So let's say we are adding a new class, and this class name I'm going to give Apple item. So now we have a class named Apple item which will implement the 3 functions that every product item should provide, because this is just the implementation of abstract details that we talked about. Now there is an interface and there is a class and there is a relation between them. Every class that we have in our software should adhere to the rules defined in an interface, because that's how we started our discussion. And it's similar to if we are constructing a building, then the person who is making the building should adhere to the rules that are defined by the architect in this map, because if he doesn't follow the rules, then building will not come in this particular shape, in this particular space. So what we are also doing is we are creating classes in the middle category and we are going to follow the rules. Now in Java terminology, we say if we define a class which adheres to the rule of an interface, we are saying we are implementing that interface. So we will go to Apple item class, and here we will use a keyword called implements. Now we are saying this class is going to implement product item interface. And when we say that, what essentially it means is whatever functions were declared in the product item, all those functions should be defined in Apple item. Now those functions should have a body here. If we click here, NetBeans will say implement all abstract methods. If I click this, you'll see all the methods that this interface had, they have been added here with a body. So let me remove the content of throw from here. Now we should be kind of implementing these functions. So now tell me, if we are implementing this here, then what should we return from get image? Because here we are returning an icon. Or let me change my interface, because the class that we used yesterday was image icon. So I'm changing the function name signature here, and I'll also change it in the class which is implementing it. So let's remove icon. and image icon. Okay. Yes, Arita. So now we are saying Apple item class should give us the image of Apple, right?
Yeah.
We
Yeah.
have an image which is copied into the project folder, and that image is under fruit images folder. So what we need to give is we need to give the relative path fruit images slash apple.png. And today we have PNGs, not GIFs. So what we will do from this function is, since it has to return something, then we will say return new image icon. We are creating a new image icon object. We are giving the file path and we are returning that. Ideally, if this is the slash we are using, we have to use double, or we can put the other slash. This slash will be single, this slash will be double, because you remember in printf we talked about slash n earlier.
Yeah.
So this slash is meant for escape sequence. So whenever we use this slash, we have to put uh, kind of double slashes, just to say that this slash is not escape sequence. I really meant as part of the string there is a slash. So any of the slashes we can use. So now we are saying this function we have implemented. Now the function has a body. It is happily returning something to the UI. Now second function was get name. Okay, ideally in real world, these functions will be these details, these images will be fetched from database. So when we go to sites like Flipkart or Amazon, then for every item, the image paths, they are really stored in the database. They connect there, they get the details from there, and then they return. Since we are doing a mini application, we are directly returning from here. Now, if we have to return the name, we know we have to return a string. So we can simply say return apple. That's what an apple will return. Again, in real world, it will be getting something from the database. The last thing is we have to give the price. So apple here we said will be costing 25 rupees, and here in our case we are saying it will be dollars. So let's simply go and return 25, and this will not be in double quotes because this is an integer.
Yeah.
So what we have done is abstractions we have converted into implementation. So we have one item which is the product item. We have converted it from the map area to something which looks like a model flat right now. Okay, so now once we have this item, for UI it's very easy to show these items details by just creating a object. So if I go to the code of this UI, if I go to source, this is the name of the class we gave mini bazaar. We'll go to the constructor because we know constructor will be called automatically whenever we run our code. Let's say as part of constructor we make an apple item object, AI equals to new apple item. Now we have an object using which we can call various functions of apple item. Now functions that are there in apple item are three functions that are defined by this interface: get image, get name, get unit price. Now what the UI will do is UI has to get the image from there, and UI has to set the image over here. So let's say the first item that we have, let's change the variable name and we call it label apple. Okay, it is image, sorry. LBL apple image. This is the label which will have LBL apple name. So I'm just renaming the label so that in code we write the readable code. LBL apple price. So we have three labels and we have renamed them so that we can show the product. Now we can go to the code, and in code we can say apple item we have. So let's do LBL apple image dot set icon, and who will give us the icon? That is AI will give. So we say AI dot get image. So we take something from apple and we set it on UI. Same way we will say LBL apple name dot set text, because the label has a text, AI dot get name. So apple item will give us the name. We'll take it from there. We set it as a text to label. Third thing is we'll say get its price. We'll say set text, because label only allows us to set text. We will say AI dot get price, or the name we gave was get unit price. So we call get unit price. Now unit price will give us a integer. We have to convert it to string so that this function can consume. So how do we convert an integer to string?
By type wrapper class.
By a type wrapper class. So here the answer that we want is a string. So we will use the not the type wrapper class here. I'll tell you why. So we'll use string value. Okay, it's a value of function. Yeah, so if we have to convert string to integer, let's say in string there was 1, 2, 3, we have to convert that to integer, then we use integer dot parse int, right?
Yeah.
So type wrapper classes are used to convert something else to this type. Now here we are talking about we have to convert an integer to string type. So string is our destination, so we'll be using the string class. Here in this case our destination is integer. We want an integer back, so we use type wrapper class of integer. If we want some string back, string x, then we'll use string dot value of, and we can give an integer here, right?
Yeah.
Or till now what we have done is we never used this function earlier. Till now what we were doing in println, whenever we were printing an integer, we were always adding it to string, because if we add integer to a string, it automatically converts that to string. Remember in system.out.println we had been printing integers by adding them to strings. So typically we say system.out.println and we say value of I plus I. So here if I is an integer, this gets added and total thing becomes a string. So we can use that concept. That is more easy to remember and do. Well, so in constructor we have these lines of code. If I go and run this now, we can see our UI got the product name. Okay, our label was little smaller to hold the image. That's why the image is little kind of cropped from here. We can increase the size of label and then the image will fit. And we are showing Apple and we are showing 25. Ideally 25 should not be shown directly 25. We should have added some currency symbol here like rupees 45 or $45. So let's do that. So let's go back to our code, and when we were adding the unit price, before that we can add a string. We can say price colon dollar space plus. So if we are adding string in the beginning, we don't need to add in the end. So now this complete thing will become a string. Right click, run file, and we can see the first item is being shown of $25. Apple also we can move little down, and let's increase the size of our label. So we increase it. Okay, automatically it has moved down. Right click, run file, and we can see now Apple kind of fits in. It's just a little realignment of this label that we have to do, and after that things will look nice. So now Sarita, you can do the same thing for pineapple and pomegranate.
Yeah.
Showing the images, showing the name, and showing the price. Okay. So great. So I'm leaving the UI part so that we can have the functionality of at least plus button completed. So now let's see what will happen when user clicks the plus button. So I right click, change the variable name, call it btn add apple. Now whenever we click this plus button, what should happen is in our shopping cart a new Apple item should get added. So what we will do is here we know because this button is for add Apple item, we should be creating an Apple item product. So we will say Apple item AI new Apple item. This is the product we have created, and what we will do, we'll create object of shopping cart class new shopping cart, and then we will say c dot add product item AI. That's how the code of this will look like, right?
Yeah.
Now shopping cart is not a class. In our case, shopping cart was just an interface, right?
Yeah.
So we cannot create the object of interface. So what we need to do for shopping cart also, we need to create a class which is implementing that interface, because we are again talking about concrete details. So we add shopping cart IMPL. So IMPL shows this is the implementation of the shopping cart interface. So here also we'll go and write implements shopping cart, because shopping cart is an interface. Now when we implement an interface, we have to define the body of all the abstract function. So we go here and you can see all 4 functions have been added here automatically by NetBeans. And now we have to worry about how do we construct this so that this shopping cart is functional. Now you will see the concepts that we talked about yesterday, they will be reused here. So yesterday we talked about collections, right?
Yeah.
Now if we want to hold many items in a shopping cart, then which collection will be more suitable? We want some collection in which we can add product items one by one. What collections we talked about yesterday? Yes, Sarita. Hard to remember? Okay, never mind. It was array list, right?
Yeah, array list.
So array list, and this array list, what type of objects it will hold? Product item, right?
Oh, yeah.
Each item in array list will be product item, and we say this is our items list. And this items list initially, let's say new, initially we have a blank array list created for us, array list, and on the right side we can create an array list of objects. Now whenever user wants to add some product here, what we will do, in item list we have an add function that we saw yesterday. Using that function, the input parameter that we are getting, we will directly add as p. So what this line will do, it will add an item to the array list, right?
Yeah.
If you want to remove something, we'll say items list dot remove, and we can see remove has a function which takes an object. So in remove we can give p, and it will remove that item from the shopping cart. If we have to give the count of items, how many items we have, how do we do that? Yesterday we talked about a function that collections will have to tell how many items they have in them. Remember, Sarita? Item list dot, there was a size function.
Size.
So size returns the number of elements in this list, right?
Yeah.
So this will give us an integer, and that integer will directly return, right? So this function will be able to return how many items are there in the shopping cart, because internally we are having a collection stored with us. Now this is the tricky part. If we have to tell the total amount of items in the shopping cart, what we will do is we will have to loop over the complete array list, and then we'll have to add the items. So let's say int total initially is 0, and we say enhanced for loop we'll use. So for product item pi in items list, because that's the array list we have. So we are saying for every product item in item list, what we should do, in total we should be adding previous value of total plus pi dot get unit price. So if that way we loop over it, then we are going over every product item, we are asking its price, and we are adding to the previous total. So if there are 3 items, $25, $45, $60, so first we'll go to first item, we'll say give me your price, it will say 25. We'll add 0 plus 25, now our total is 25. Then we go to second item using loop, and we ask what is your price. Second item says mine is my price is 35. We get that price, we add to total, and that's how we calculate. And after we are done, we simply return the total. So this function will work on getting us the total from shopping cart, and shopping cart implementation is the class responsible for giving that to the UI. So Sarita, this makes sense?
Yeah.
Any questions here?
No.
Okay. So now our UI, what it has to do is it will simply use this shopping cart implementation. Now this shopping cart implementation will be used here, and every function of this class will need it. I'll tell you, this function is going to be called whenever we click the button, right?
Mhm.
So that means previously whatever we have added to the shopping cart, that should still remain. So our shopping cart will not be the local variable here. That will be a class level member in mini bazaar. So every mini bazaar will have a shopping cart sc equals to new shopping cart. Sorry, it should be implementation because we are creating the class object. So this is our shopping cart object. Now in this shopping cart, we will be adding an item whenever user clicks the plus button. So plus button gets clicked. This creates a new Apple item, and we are saying shopping cart dot add product item. After we have added the product item here, next thing that UI has to do, whenever user clicks this plus button, first thing is this item should get added to the shopping cart. Second thing, the UI should display here that total items are 1 now, and this is the total price, right?
Yeah.
So second thing that we should do is we should update the UI, update the UI for total count and price. So what we will do is here UI will say LBL. Okay, I should rename those variables so that we can set the value. So this is the total items. So let me edit the variable name, right click, change variable name, LBL total items count. So this is the label that we have to update. Go here on this plus button, click, we should say LBL total item count dot set text, and the text will show items. In the bracket it will show the count because we have to say items bracket start count bracket close then colon. So we are saying items bracket start plus sc dot get items count. Your shopping cart is going to tell us how many items are there. Another plus, and we close the bracket. So item count is added. Then we put a colon, and we are done by showing the items count. So this line is clear.
No, can you please repeat this line?
Okay. So what we have to show in the UI is items 1 bracket close. This 1, 2, 3, 4 will change, and this 1 is coming from shopping cart because shopping cart will tell till now how many items it has, right?
Mm-hmm.
So in this there are three parts to construct this. The first part is fixed, which is items and round bracket. This is fixed, this is not changing, right?
Yeah.
After that there is some integer that has to come from shopping cart. So what I'm doing is sc dot get items count, because this function will return and tell how many items are there now. So we added a string which is fixed, then we added a variable which is changing, and in the end again we add a string closing and putting this. So this constructs the full string that we want to show in the label.
Okay.
Clear?
Yeah.
Okay. Same way, the second string also that we have here, we want to show dollar and zero. So let's change the variable name LBL total price, and here we have to show dollar space the price. So we go here back on plus button, click, and we will say LBL total price dot set text, and here what we are going to say is we are going to put this kind of string $0, right?
Yeah.
Now this 0 is going to come from the shopping cart, so we'll say plus shopping cart dot get total amount. Clear?
Yeah.
So on click of plus button, we are creating an Apple item, we are adding to the shopping cart. Then UI is asking shopping cart, can you tell me the total count, total price, so that I can update myself. Now let's right click, run it. If we do a plus click, you see the items is 1, this is 25, because on click of plus there is an item that is added to the shopping cart. Then these two labels are updated based on the things that shopping cart is returning us, and shopping cart is a very object oriented thing that we have designed, which is interacting with us in the form of functions, right?
Yeah.
Now if you see, shopping cart has both the types of members. It has data member items list, it has function members, which is this. Clear?
Yeah.
Okay. So now one thing is working. Now same thing has to be replicated here. This plus should also work. This plus should also work. And we will not pay attention to the minus symbol right now because that will be a little complicated if we try to bring it in. So what I'm going to do is, because that will require some more concepts of Java, so for now we will not implement the minus functionality. So let me go to properties of these buttons and let me disable them. So there is a property here, enabled. Let's see if we can figure out. There is enabled property. Yeah, enable is ticked, which is true. If I uncheck that enabled property and we say close, then these minus buttons will be disabled and user will not be able to click them. You see these buttons are disabled.
Yeah.
So when we implement that functionality, we can enable them. Okay, so this was the main case study that we have done. So we started with abstraction. In abstraction we created interfaces. Then we started implementing that interface, and we used the concept of implementation. And there, it's somehow we can say inheritance was involved, because in inheritance what we did, we were implementing the functions, exact functions that are declared by the interface. Same, these functions were implemented in the classes which are implementing them. So this implements, we can say we are somehow related. This class is related to this interface, right?
Yeah.
Okay. So now let's say after apple item, we have to define one more class, which is the pineapple item. So
Yeah.
if we go and we add a new class, right click, new, and here we will say Java class, and let's say pineapple item, and let's create that class. Now this class will also adhere to the rules of implementing the interface, implements product item, so that all our items that we are selling, they are uniform. So we implement abstract methods. All three methods have to be implemented here again, right?
Yeah.
So now let's say going forward the requirements change, and requirements say every product that we are selling should also have the seller's name. Typically you would have seen on Amazon, some items Amazon sells itself, some items it sells from third party sellers, right?
Yeah.
So we say in product item interface we need another thing, and we call get seller name. So this is a function which will tell who is selling this particular item, right?
Mm.
This is clear?
Yeah.
So now since interface has one more function which is abstract, the classes that are implementing this interface, they should also implement it inside them. This function, get seller name. And right now let's say only we are the sellers. So what I'm going to do is the implementation of this function, I'll say return being 0 is the seller. Same way we go to apple item, and in apple item, okay, here there are some functions that have to return some string and they are not returning, so it is giving error. So I say this is pineapple, the unit price for pineapple is, let's say, $45, and for image we kind of go to apple item, and all we have to do is we just have to take it, we paste it here, and for this I think there is the name of the image is pine. Okay, this is pineapple complete, so we have to put that path. Okay, so what we are saying is the get seller name is being 0 here, and in apple item also this function should be implemented, and here also it will be being 0. Right, so far clear what we have done. We have added one more function into product item, and we are implementing that also in classes. Right, Sarita?
Yeah. Yeah.
Now the challenge you see, let's say this function was of 20 lines of code, get seller name, because it connects to some database, it fetches the data. So the problem that we have introduced, you can see, that is we have duplicated the code of this function. This function in this class is same, and in this class also it has same implementation, right?
Yeah.
Now we want to avoid this duplication. We want to say that we should have one function written only once and it should be reused wherever we want to call this. That is where inheritance comes into picture. So what we do is, for inheritance, we introduce one more class uh, in between this hierarchy, and let's call that class abstract product item. And this abstract product item is actually a class. Just first understand what I'm doing, then I'll explain you the benefit of taking this approach. Now what we are saying is this class will implement the real interface of product item. What it will do is it will not implement all the functions of our interface. So it is going to implement only one function, which is get seller name. And here we will return being 0. So clear, Sarita, what we have done? Hello?
Yeah.
Yeah. So Sarita, what I have done is I have defined one more class which is implementing this interface, and reason of introducing this class is so that the common functions that every class needs, they will have just one implementation of that function. So right now get seller name is defined here, and this is same definition that two classes need, right?
Yeah.
So now what we are going to do is we are going to change our pineapple item, and we are saying it will not implement product item, it will extend our class which is abstract product item. And same way the apple item will also extend the class that we have defined. Rather than implementing the interface, we'll extend the abstract product item class. And abstract product item class, ideally it should have implemented all the 4 functions defined in the interface, right?
Yeah.
But it is defining only one function. That means it is getting 3 more functions from the interface which it is not defining here. So this class has 3 more functions. As part of it, they are inherited from the interface, but they are abstract in this class also. That line is making sense, what I'm saying?
No, I didn't get that line.
Okay. So whenever we are implementing an interface, it's a rule, it's a foundation of us that we should be implementing all the functions of that interface. If we do not provide the body of all the function, what that means is this class is also having some functions inherited from interface, but they are still abstract. This line makes sense?
Yeah.
If I say I have 4 work items assigned to me, and none of them I have done till now. When I am going on leave from my office, let's say my manager says Sarita will take over the work from you, right?
Yeah.
So I will tell Sarita, these are the 4 work items that manager had assigned to me. I am giving it to you. So that is what this implements keyword is doing. Interface did not do any work. When we say implements, this class is inheriting all the functions from that interface, right? Now all
Yeah.
those 4 functions have to be implemented here in this class. Now let's say
Yeah.
Sarita took 4 work items from me and Sarita completes one of them. Other 3
Yeah.
are still incomplete, right?
Yeah.
So Sarita still has 3 abstract items with her which are not yet implemented, which are not yet done, right?
Yeah.
So a class that inherits abstract methods, that chooses not to define the body of any functions which are abstract, that class becomes abstract by default.
Okay.
When we put the keyword abstract here, this abstract tells this class is having certain functions which it chose not to implement. If a class has an abstract function as part of it, then we call that class as abstract class. Now the means of this class is like saying this class also has 3 functions which are public and abstract. So we implemented only get seller name. We go to this class and we define other 3 functions here, and let me call them, this is public abstract. That is the state in which this class is right now. because when it implements an interface, it inherits all the methods from that interface. Now class may choose to implement to provide body of a method or to leave defining the body. If class chooses not to define body of these methods, then the class is set to have certain abstract methods. And a class that has abstract methods as part of it, that class must be marked as abstract class. Clear?
Yeah.
So this we can say abstract class is the partial implementation of a class. It will have some methods completely defined and some methods left as abstract. Now it is making sense?
Yeah.
Okay, great. Now this class is inherited by Apple item. Now we go to Apple item class and we will see what Apple item is doing. Now Apple item is inheriting from abstract product item class. Now what Apple item will get? There are four work items that abstract product item had. One it has implemented, other three it has not implemented, right?
Yeah.
So we can say Apple item is inheriting four work items, three of them are not yet done. So what Apple item has to do, it will give implementation or functions only of those, body of only those functions which are not given in the abstract product item class. Now it can choose not to give this implementation get seller name, because that is already done by the superclass or the class from which it is inheriting. Clear?
Yeah.
The benefit that we got is we don't have to redefine, we don't have to redo the work that is already done in the class abstract product item.
Yeah.
Now if we go to pineapple item, here also we are inheriting from abstract product item class which has three abstract functions, so we implement all of them and we get rid of get seller name. Now clear?
Yeah.
So now if we go to our UI, for every product item we will see, if I say AI dot Apple item dot, you see Apple item still has get seller name function, even though we did not define that function inside the Apple item class, because it is inheriting that function from a class above it.
Okay.
Right? So with that, if I show you the modified architecture of our project, then it looks something like, I'm jumping to the last slides after polymorphism. Yeah. So what we have done is we have changed the structure to this. Here the fruit item, it's the old way of writing. You can consider this is a product item, right? And
Yeah.
okay, I think this is the old design. Today I took another way. So I will use a function star UML. There's a software called star UML, or we can go online and we can draw a diagram. Let's say UML diagram. That is a way to define the how we have kind of laid out our classes. So there are online tools available. Let me draw a diagram, not this. Okay, Creately is the popular one. Creately, if we go there, try now. So basically this diagram will help us summarize whatever we have done till now.
Okay.
So we can show that graphically. So in this, when I go, okay, basic shapes are coming. Creately UML diagrams. Okay, actually I uninstalled my star UML 3 days back. Otherwise I would have quickly shown you. So this diagram that is there in the slide, this diagram is made using that software, Apple item, pineapple item. Online UML diagram. Yeah, so coming back, okay, I was trying to search online resource to create UML diagram, create UML diagrams online, and we were searching for YUML and Creately. Okay.
Yeah.
So GoPro, I don't want to GoPro, I want to try something here. Okay, I have used creately earlier. Yeah, start drawing now. Okay, so basic shapes, and let me see where are the UML shapes here. Use case diagram, and we are looking for class diagrams. Yeah. So here if we go, then what we will do is we started with interface. So let me drag and drop an interface here, and let me figure out a new way and a way to create a new diagram. Yeah. So I click new here. We have recorded an error in creately. Okay, ideally it should have given me a blank page. Let me remove this content that they are showing. Yeah. So what we did, we started with two interfaces separately. So this is an interface. In this interface, we can go here and we can add some methods. So if you see, we added interfaces. Then what we did, we were directly writing the classes that were inheriting from the interface. So earlier our Apple item inherited from that interface, right?
Yeah.
Which made it a mandate on that class that it should be implementing all the functions declared in the interface. Then we added a pineapple item class which also inherited from this interface, implemented this interface, and we have to give the body of all those functions here also. Then what we realized that going forward, if there are some methods which are there in this class as well as this class, and both of them are same in the implementation, then it will make more sense to have a class defined on top from which these two classes are inheriting. And we talked about
Yeah.
earlier, the purpose of inheritance is to inherit the common functionality that is already written for us, right?
Yeah.
So we
Yeah.
broke these relations which were direct implementing the interfaces, and we introduced another class in between just to have the implementation of those functions which are duplicates. So this is the relationship now we have. So our middle class that we have, that is implementing the interface, and in turn these two classes are inheriting from this intermediate class.
Okay.
Then we said this intermediate class will not give implementation of all the functions. It will give implementation only of the functions that are common to this and this class, right?
Yeah.
So this class is going to implement only those functions here which are common. Rest of the functions this class will not give a body to. Since this class is not giving body to all the functions of the interface, that's why we said this class has to be marked abstract, because even this has certain items which are not yet implemented.
Okay.
Make sense?
Oh, yeah.
Yeah.
Now it is clear.
Yeah. So now the things will become clear why the introduction of abstract class is required, because we could not have
Yeah.
implemented any method here. Interfaces do not allow us to implement the methods. Either we keep the duplicate copies here, or we move the duplicate copy up and inherit from that class.
Yeah.
Right? Well, so that is what we have done. Now in NetBeans, if we go and take a look, then NetBeans also helps us with these details. If I go to my pineapple item class, here there is an outline view. It is showing pineapple item is inheriting from abstract product item. You see this pineapple item colon colon abstract product item.
Yeah.
If I go to abstract product item, it says abstract product item is inheriting from product item, right?
Yeah.
So this is
Yeah.
how the relationship is defined in our classes, and if we have to draw the diagram in Creately, then there is some notation that we follow and the linking we do. So this class will implement the interface, this class will inherit from the class above it. So practically we have covered what was needed, and we have completed, we can say, the abstraction we have completed in detail. Now the only thing that we have touched upon is inheritance, and now let's take a look at inheritance. Now inheritance is always class to class or interface to interface. So I will right now I'll talk only class to class inheritance. That means one class can inherit from another class. What that means is all the members of this class will be inherited by Apple item. Be it data members or functions, all of the members are directly taken from the superclass. So this class is called the superclass, which is being inherited, and this is called the subclass, which is inheriting. That makes sense?
Okay.
So your children
Yeah.
are your subclasses. You are the superclass for them. Our grandparents were our superclasses because they had certain things implemented. They had certain features in them from which we inherit some portion of that. But here we can say when we inherit from one class to another, we kind of inherit all the data members, all the members of that class. And the main reason we inherit one class from another, the reason is simple. We want to reuse the functionality that has already been done there.
Okay.
So if a car making company is coming up with a new car, they don't create all the parts from scratch. So Tata may come with a new car, Nissan may come with a new car, and Nissan may say, I already have made it a gear unit, I already have an engine, so let me reuse those engines and those bodies and let me customize the rest of the details in my car. So some level of inheritance of using old experience will come in, right?
Yeah. Yeah.
So if we have to summarize the concept of inheritance, okay, first let's summarize the concept of abstraction. In abstraction, we covered interface first, then we covered abstract class. Abstract class is the one which is a class that may have one or more methods unimplemented, right?
Yeah.
So that means it can have some methods which are implemented also. Then we come to concept of inheritance. Inheritance has a concept of superclass and subclass. Here we simply say class sub extends super. This is the syntax we follow. What it means is all the members of superclass are automatically inherited by subclass. That makes sense? So inheritance is only this much concept, covering of the concept of extends, and there is one more keyword, super, which is a this like keyword that also we will cover in a short while, and that way we will say our abstraction and inheritance will be covered by today's class. So this one I'm leaving at this stage. I hope from here you will be able to take forward, because most of the heavyweight work we have done. Only you have to put two more images and you have to make these buttons functional so that this shopping cart is updated based on any interaction we are doing, right?
Yeah. Yeah.
Okay. So now I will cover one more example of, let's say, inheritance. So here in inheritance, the example that I had listed in the this was, okay, I will not cover the mobile phone example because we have talked about that example a lot. So let's say we are talking about a car and a sports car. So car is a class. Typically a car will provide us features like, let's add some members here. We say int max speed, because every car will have its limit of what is the max speed that it can reach out to. Then it will have, this is the data member, one representative data member that we have added. Then second member we are adding is, let's say, void accelerate, and let me add one more member, current speed. When car is running, what is the current reading it is showing in odometer. Now this is a car class that we are having. Typically, do you play computer games, Sarita?
Yeah, but not much.
Okay, not much.
I used to.
Okay, so there is a computer game called Need for Speed, which is a car racing game.
Oh yeah, I know that game.
Okay, so there the car that we get for racing for participating in a race is essentially object of a class that has been defined in that software. So when you say, when you are given 10 options, when you are picking one car, then software will be creating object of that car and giving that to you. So it will have some attribute. It will have its max speed, current speed. It will have some color. It will have some kind of you can say the brand, it's Audi or it's Mercedes. So essentially it will be a class in the software design, internal details of that, right?
Yeah.
Now let's say sometimes in the gaming, what happens, we get some powers, we eat some coins, or we run for some distance without hitting any other car, so our car attains some points, because of which, let's say, they give a boost of power to us, and they say now your car can run at some extra speed.
Yeah.
So what that does is, we can say there is a separate car, another car which has some extra features than this car. So we define another car class and we can say sports car. Now, what this sports car will be, this sports car is also a car, but it has certain extra features than the real car. It may be less number of seats, it may be having then some more advantages it will have. Or if it's a luxury car, or it's a kind of, you can say it's like a Mercedes car, then it will have advanced security features. It will have airbags, it will have some ABS system into that. So when we are defining another car, we can say sports car will also have an accelerate function.
Yeah.
Now, if this function is written here, some, let's say, coding is done, 40 lines of code is already there, then it has two members, max speed, current speed, and all these members are also required by sports car. Then one option is we copy all of them and we paste inside the sports car. Or second option is the sports car that we are defining, it is inheriting from car. Clear?
Yeah.
Now, when it is inheriting, ideally there is no member defined here, no members here, but still we will say sports car has three members inherited from car. I'll show you how we are able to say that. So let's add a car test class, enter, and here we are going to add a main. We'll say PSVM, enter. So here we will have a car object, car C is equal to new car, and if I do C dot, you see current speed is there,
Yeah.
max speed is there, accelerate is there.
Yeah.
Because
Yeah.
car class has defined all three members and we are able to access all of them using an object. Now in car test, what if I make sports car object, SC is equal to new sports car. Now tell me, if I do SC dot, will I get to see all those members or not? Sarita, what is the gut?
Yes.
We should be, because
Yeah.
those members are inherited. So if I do
Yeah.
SC dot, current speed is there, max speed is there, accelerate is there. So that is the benefit of inheritance, that we can inherit the existing members rather than writing the duplicate code, and all that functionality will be automatically there. Now in sports car we may have some additional functions, like we can say it has some boolean member, we can say it has ABS feature, and this will be true for sports car, and this feature is not at all there in the car. So this member that it has, you can say this is a unique feature, this is more specialized car than the super class that we are having. So here sports car represents the subclass and car class represents the super class. So super is used as in grandparent versus parent. So car is a super class, sports car is a subclass.
Yeah.
So inheritance is also clear.
Yeah.
And in our case, we used inheritance at two levels. One, we were inheriting from the interface by using implements keyword. Product item was implemented by abstract product item. And then we were inheriting abstract product item class in Pineapple. So keyword
Fine.
extends and implements we have discussed, right?
Yeah.
Okay, then that is where we will be ending our discussion today. And I'll show you the summary that with which we started initially. Yeah. So now you take a look at this abstraction and inheritance. In abstraction, we covered the concept of abstract functions.
Yeah.
What is an abstract function? The one
Abstract function which don't have body.
which do not have body. That is abstract function. Then we talked about the concept of interface.
Yeah.
Interface is a concept where an interface can contain only abstract functions,
Yeah.
no data members, right? Then what is an abstract class? It's a class that can contain data members. This can contain implemented functions, and it has one or more not implemented functions. So if a class contains an abstract method as part of it, as abstract function as part of it, then it becomes mandatory for us to mark the class abstract, just to indicate that this class does not have all the parts clearly defined, clearly implemented. Make sense?
Yeah.
So we can say a class that has even a single abstract function, then it makes mandatory to mark the class as abstract.
Okay.
Then implements keyword we used when a class implements an interface.
Yeah.
Right? So that winds up our abstraction. Then if we talk about inheritance, we talked about extends keyword. One class inherits from another. So we'll say class A extends B. That means A is inheriting from B.
Yeah.
Now yesterday we used a concept called this keyword, right?
Yeah.
So this keyword represents, in a class, it represents the object of current class. So I can say in sports car we have a function, let's say public void apply accelerator boost. So here if I say this dot has ABS, so we are able to access the data member of the same class using this keyword, right?
Yeah.
Now imagine if we want to access the data member or a function member of the superclass of car class, then we can use a keyword named super dot. Then you will see all the superclass members we can access like that.
Mm.
So super keyword is similar to this keyword, but the only difference between this and super is this is refers to same class object and super refers to object of superclass. This way we can access superclass member, this way we can access current classes member. Clear?
Yeah.
So that is the relation between super and this.
Okay.
So whenever you will see in any class super dot is used, you can clearly understand that this is trying to access a member of superclass. It can be a data member or it can be a function. Ideally, these two keywords are not mandatory to use. Here, if I don't use this keyword, I can still access the data member of the class. Here, if I don't use super, I can still access the current speed because current speed is also inherited in this class, right?
Yeah.
So this class still has that member inherited, but sometimes there is a need to use this keyword and super keyword. This we talked about yesterday. The main use of this is to disambiguate between the function parameters. So if this function had a parameter has ABS, now this is helping us understand that this has ABS is the class member, and if we directly write has ABS without this keyword, then we are referring to local variable or the input parameter. So this is the disambiguation we are having, right?
Yeah.
Now in polymorphism we will see sometimes we change the behavior of our previous experience. That is what I said to you initially, right?
Yeah.
So in superclass we had accelerate function. Let's say we want to give a new implementation of accelerate. We want to change the implementation, then that function can be defined here also. Now we have the copy of a function that was defined on top, and we say we are giving new implementation. That means we are customizing our experience,
Mm.
right? Now there is a confusion in this class. We have two functions to call. One is superclass function, one is current class function. So if I say this dot accelerate, we are saying call current classes implementation. If I say super dot accelerate, this is call super classes implementation. Make sense? Yeah, so whenever there is an disambiguity, that current class also has a member with the same name, superclass also has a member with the same name, and both of them are different, then using super keyword, we can be specific, we are using the superclasses implementation. Using this keyword, we can say we are using current classes implementation. And if we don't put the this keyword, it is by default assumed that we are calling current classes implementation.
Okay.
So this is implicitly assumed. Super is to be specifically like we are calling the superclasses method. So that is what is the correlation between super and this. Both are used inside the functions of a class, and both are used to access either data members or the functions of a class. Clear?
Yeah.
Okay. So with that, we can say we have covered abstraction and inheritance completely. In slides, I also included certain questions, so let's go over them. We still have 2-3 more minutes to go. So now let's cover the remaining concepts. So we started with constructing a building, constructing a software. Now let's take a look at abstraction. It's act of focusing on essential features rather than worrying about internal details. Ideally, I should say implementation details.
Yeah.
So this is abstract view of a flat. It focuses on what rather than how. It is very useful concept when we convert ideas from specifications to code. That means requirements when we want to convert to code, then we begin with inherit interface abstraction, and it becomes easy for us to build software. It provides flexibility of changing the implementation anytime. Because we are focusing only on what part, this is the picture we have given to a client or customer that this is the kind of flat we will make, right?
Yeah.
Now, since we did not talk about how we are going to make it, it's up to us whether we put 10 labors on the site or we put 50 labors on the site. So implementation, we have always flexibility of changing. But if we commit to someone that every day 100 people will be working on this site, someday if customer comes and sees there are only 10 people working, he may object to us that you claimed that you will show 100 people and today only 10 are working. So if we go with abstraction, we never show the internal details. We only say to customer, you will get this thing ready, leave the implementation on to me. Another detail of this last line is in our code, what we did was in our shopping cart, we used an array list, right?
Yeah.
Now, consumer of this shopping cart should not be bothered about internally we are using array list or we are using array or we are using hash set. So this is something that we are saying other person should not worry about, so that tomorrow if I want to change this item list to hash set, I should have that freedom with me. Or let's say in next version of Java, they introduce any new collection which is far powerful than array list, then we will have a freedom of changing it internally anytime without changing the behavior of the client. Clear?
Yeah.
So that's the power abstraction gives us. Then abstract methods we talked about. A method which does not have a body, that will be abstract method. Then we have a concept of interface. So again, there is some theory. You can read to it in your free time. I'll upload this deck. Then the question comes, why use interface? Again, some theory is there. And then we directly jump onto the concept of inheritance. And here I had taken example. If we are defining a phone emulator, we have a mobile phone and we have a smartphone. Like we took example of a car and a sports car. This will have less features, this will have more features. So it makes sense for a smartphone to inherit all the features of basic phone and add the new features. So basic phone did not have a feature of clicking photo. Smartphone has a new feature of clicking photo. Right? Yeah, so this is inheritance. One is called base class, second is called derived class. In Java world, base class is called superclass, derived class is called subclass. Okay, constructor invocation we will see with polymorphism. So in which order the constructors will be called, that makes more sense to talk about when we cover polymorphism. Then we talked about super keyword in inheritance, right?
Yeah.
Okay, superclass, subclass, these are again the concepts. Again, we will do this with polymorphism because there it will make more sense about object references. Okay, one more important thing that I forgot to cover was Java does not support multiple inheritance. That means in Java, one class cannot inherit from multiple other classes. That is
Okay.
clear? One class can inherit only from one other class. That's defined in Java. You
Okay.
can never have a class which is inheriting from two other classes. So interview questions are, people ask this question, is abstract class, if abstract class is there in Java, then why was the concept of interface required? Because ideally, to define abstract methods, we can have an abstract class and we can have abstract methods declared there, right?
Yeah.
Then why Java introduced a new concept called interface? Now, answer to this question is one class can inherit from one more class, right? Multiple inheritance is not allowed. But
Okay.
a class can implement more than one interface. That is allowed in Java. So interfaces serve the purpose of multiple inheritance indirectly. That is the main reason where interfaces and abstract classes differ. So take an example of you and me. We support multiple interfaces. So Sandeep or person, any person, it implements multiple interfaces. So we can say we implement a student interface, right? At some point in our life we were student. That time our functions were,
Yeah.
we had to mark our attendance, we have to submit assignments. So student is an interface which will have functions like uh, attempt examination, attend classes. Those are the functions we'll have. Then as a person we also implement an interface of son or daughter. We can say a child. Then we also
Yeah.
implement an interface of parent somewhere. We are parents to our kids. Clear?
Yeah.
So in real world, in software also, it becomes a need that some classes they adhere to rules of lot of interfaces. So implements keyword can be used for multiple interfaces. That means a class can implement more than one interface, but a class can inherit only from one another class. Person extends, or we can say female extends person. And you can look around more on internet for this question, but key difference is this. Now sometimes people ask explain with an example, so reading online on sites will give you answer to this particular question. Make sense?
Okay. Yeah.
Next is, what is the benefit of class implementing multiple interface? So I have just given you example here. Sometimes a class serves more purposes. In software world, we can say if we have a web page, then web page will, sometimes you will see if you are admin on the site, you will see a lot of additional features available to you on a site. Have you ever done administration of some site?
No.
Okay, so so what happens, like in Gmail, we are just the consumers. So there will be some administrator of Gmail. If he goes there, he can block some people's account or he can retrieve their password and he can help them. So administrator always have more powers than the users as users that we have to a software system, right?
Okay. Yeah.
So a web page can implement multiple interfaces, and one of the interfaces is admin, one is the user. So if we say a web page is implementing admin and user interfaces, that means we are saying a web page should serve both the needs of admins as well as user. Now admin will have separate set of functions, user will have separate set of functions. So need to multiple implementation arises because one class can have different interfaces for different kind of users. For admin, this web page can look different. For user, it will look different.
Yeah.
What is difference between abstract class and interface? I assume this question can be answered easily. An abstract class can still have implementation of one or more method, right?
Yeah.
Interface can never have implementation. That is one difference. Second difference is an abstract class can have data members, but interface cannot have.
Yeah.
then abstract class can be inherited by one other class, but interfaces, more than one interfaces can be implemented by any other class.
Yeah.
So these are the some of the differences between interface and abstract class. And yeah, those are the questions that I had listed here. Then you can go on theory of abstract class. There are some questions listed there also, and that is where we are winding up. I do not have any questions listed on inheritance, because inheritance becomes more complex when we talk about inheritance in conjunction with polymorphism. So that is what we will cover in next week. There we will see some questions of inheritance and polymorphism. And in the diagram also, if you see, I clubbed both of them together because they become powerful when they work together, inheritance and polymorphism.
Yeah.
So we will cover those details next week. So that is where we'll wind up today's discussion.
All right.
Fine. So yeah, any more questions you have?
No, but you will upload this video, isn't it?
Yeah, I'll upload the video as well as the deck for you.
Okay.
Yeah. And yesterday's video is already up. I hope you got a chance to see that.
Oh, no, I didn't get a chance.
Fine. So yesterday's video is already online, and today's video also I'll post, so that in this week you are able to go over these content also. Yeah.
Okay.
Okay, Sarita. Then we'll be closing the class. See you in next week.
Okay. Yeah. Yeah. Thank you, Sandeep.
Okay. Thanks, Sarita. Bye.